Hello, everyone. In this section, we will focus on another capability of drones, a visual perception. A drone does not only need to move through the environment, it also needs to observe and understand its surroundings. Cameras provide visual information that can later be used for tasks. AirSim provides a convenient camera API that allows us to capture images directly through Python. An AirSim drone has several cameras installed at different positions. These include the front center camera, the front right camera, the front left camera, bottom center camera, and the back center camera. For backward compatibility, AirSim also supports numerical camera IDs. The front center camera can be accessed using 0, the front right just using 1, the front left using 2, the bottom center using 3, and the last back center using 4. In this notebook, we will use the front center camera. AirSim can generate 8 types of images. The most common type is the SIM image, which is similar to what an RGB camera will capture in the real world. And AirSim also supports multiple depth image formats: segmentation image, surface normal images, and optical flow images type. Now, let us move to the Python code. We first check the Python packages. And install the libraries required in this section. OpenCV is used to decode, process, display, and save images. Matplotlib is used to display images directly inside the Jupyter. Pillow provides additional image processing support. Next, we could create a multi-rotor client object and call confirm connection to connect our Python program. As in the previous section, we enable API control, arm the drone, and send the takeoff command. After takeoff, we define 2 important variables. The first variable is camera names, which is set to 0 just using the front center camera. The second variable is image type. Therefore, we will obtain normal color images. To retrieve an image, we call client sim get image. This function receives the camera name, the image type, and optionally the vehicle name. For a compressed sim image, the return result is a sequence of binary bytes. These bytes cannot be displayed directly, so we must convert them into an RGB image. In this section, the program captures the images with a 1-second interval between each acquisition. After image acquisition is complete, we land the drone, disarm it, and release API control. It will cost some time. The next part introduces multi-threading. Visual processing can require significant computation. If image acquisition and flight control are executed in the same sequence, image processing may delay the control commands. Using separate threads allows different tasks to run concurrently. However, there is an important AirSim requirement. Each thread should create its own multi-rotor client instance. In the show function, a new client is created specifically for the image thread. The function captures three images, converts each response into an OpenCV image, and saves the result as a JPEG file. The notebook then discusses multiprocessing. The example creates another AirSim client for camera acquisition. In a complete multiprocessing application, this second client and the image processing loop will be placed inside a separate process. And that's the result. Finally, let us look at the camera detailed configuration. AirSim normally reads its configuration from the setting JSON file. This is a JSON text file with multiple sections. The camera configuration is located under the vehicle section. For example, if you have a drone named Drone 1, its camera configuration will be under the Drone 1 object within the vehicles. The file structure looks roughly like this. And to set camera resolution in the configuration file, just add the corresponding entry in the capture settings array. And we could also change the frame rate, field of view, and the camera type configuration. After modifying the setting JSON, just save the file and restart the AirSim simulator for the camera parameters to take effect. And you no longer need to set these parameters through the function calls. AirSim will automatically read the settings from the configuration file. And that's all. Thank you.